Thank you everyone for joining this webinar about how you can connect Phoenix to your PK/PD analysis and reporting workflows. So less than 10 years ago, PK/PD analysis was a simple process of collecting data from 2 or 3 sources, maybe the case report form or CRF, the bioanalysis results, and maybe some other analytical lab that provided pharmacodynamic results. This data was formatted for analysis using some customized formats, and then analyses were performed by the kineticists using WinNonLin. Then these PK/PD analyses output was used to create tables, figures, and listings, and eventually the study report. While this was very simple to execute, these methods were difficult to replicate and review. The industry, on a broader level, met and decided to standardize data formats for clinical data called the Study Data Tabulation Model, or SDTM, for the clinical studies, and the Standard for Exchange of Non-Clinical Data, or SEND, for non-clinical studies. The purpose of the standardization was to enable information system interoperability and improve medical research and provide traceability for data from collection to reporting. So I have a poll question that should have popped up here for you, and just like to know if your company is using SDTM or SEND datasets right now in the work that you do. You can just click yes or no, and then click submit. So this new standard created a continuous link between data collection and reporting, but it added a lot of complications, especially with existing software packages that were built on the previous paradigm. So once SDTM was released, existing software packages were simply connected to the new data stream. But all of the study data was imported into these SDTM datasets, but these are organized for data storage and not necessarily analysis. So we had to create analysis data sets that were derived from these SDTM data sets that can be used by our analysis software. And then the results of the analysis are placed in another analysis data set, which is then re-imported back into the SDTM data sets. And then we're starting to produce pharmacokinetic tables, figures, and listings from these analysis data sets. And then finally, we arrive at a clinical study report. So there was a heavy cost to the system interoperability and standardization because the process became significantly more complicated. And when it became more complicated, it became more error prone. So here's the results of about half, a little more than half of the listeners are actually using SDTM datasets or SEND datasets. And many people may not be using them actively in their analyses, but they're definitely required for submissions to the FDA for NDAs or another project. So with this increase in complexity, the Phoenix platform was built with this in mind, and Certara recognized that there was a disconnect between the standardization process of data sets and the overcomplicated analysis process of multiple different formats. And so they created the Phoenix Connect module to allow direct integration of SDTM datasets into a Phoenix workflow. So now these SDTM datasets can be directly imported into Phoenix, where you perform your pharmacokinetic analysis, and you can directly export SDTM-compliant datasets of the pharmacokinetic and pharmacodynamic parameters. Now you can create your pharmacokinetic TFLs directly from the SDTM datasets that have been standardized. So in essence, Phoenix Connect allows you to connect your analysis software to the standardized datasets instead of working through a series of analysis datasets and programming steps. The reduction in complexity can reduce errors and analysis time and help you achieve higher quality output in shorter turnaround time. So this looks a lot like the original paradigm where you went directly from data to analysis and from that analysis to your report flow, but now we're utilizing the standardized data set. So here's another visual representation of how Phoenix Connect works, and it sits at the interface between the standardized data sets and the WinNonLin analysis software. For pharmacokinetic analysis, there are 3 primary input domains from SDTM and 2 output domains. The input domains are PC, or plasma concentration data, DM, or demographic data, and EX, which is exposure or dosing data. Phoenix Connect performs merge procedures on those input data sets that allow you to analyze the data using WinNonLin. Then Phoenix performs an export procedure to produce the two output domains, PP, which is the plasma PK parameters, and RelRec, which is the relationship record. In essence, Phoenix Connect provides a link between your analysis module and the data inputs and outputs. But Phoenix Connect provides much more functionality than just interfacing with SDTM datasets. This multi-purpose knife visually represents the many capabilities of Phoenix Connect. It can be used to execute other software packages such as NONMEM, SAS, R, and SigmaPlot. You can then utilize existing software through the Phoenix interface in a single environment. I'll show you an example of this coming up. The Connect tool contains a reporter object that creates a Microsoft Word file with all of your tables, figures, and listings. And these reports can be updated when the analysis is updated with a single button click. So we already discussed the CDISC data standards and how Connect works seamlessly with that. It also works with the Phoenix knowledge base server if your organization uses that as a repository for your data and your analysis results. Apologize, I'm waiting on the next slide to come up. So we'll now move to the software demonstration where I'll show you three separate functions of Phoenix Connect and how this tool can integrate with your PK/PD analysis and reporting functions. First, I'll demonstrate how to incorporate CDISC datasets into your analysis workflow by showing you the import procedure, analysis dataset preparation, and the PP data export. I will then show you the reporter object and how it can be used to export tables and figures to Microsoft Word. And I'll end the demonstration showing you how to integrate a third-party software package into Phoenix. In my example, I'll show you how to produce a custom plot with the statistical software package R. However, this would be applicable to any of the software packages that Phoenix Connect supports. So now we'll move to the software demonstration. 1 minute.
Okay, we'll start with our demonstration of some of the tools within Phoenix Connect that you can use to make your life a little bit easier, in particular how to handle SDTM datasets so that you can easily analyze them without a lot of programmer support to reformat a dataset. So I'm going to start with this project here. There's a nice workflow that we have laid out. Everything is pink or red because there's no data in this project yet. So we're going to import some data using the CDISC import tool. And there's two ways that you can get at that. You can go to custom import, and you can come over to the CDISC SDTM data, or also the send data. So if you click that link, that will take you to the import screen. Or you can also come directly to the CDISC menu item. You come down to the type of data that you want and the import or export procedure. So we're going to import SDTM data. So it just takes you to a place where you can select your SDTM domain files, and it accommodates two formats. The SAS transport file is the most common format. However, your company may use a different format. And I have three example files here. You can import all SDTM files that you want. But we only generally need three. DM is the demographics, EX is exposure or the dosing information, and PC is the plasma concentration information. There are other times that you might need lab data or other supplementary data sets if you're doing pharmacodynamic analysis. We're going to select these three, And importing is as simply as selecting them and opening them, and it runs through a process where it automatically imports all of that data for you. It also identifies any validation messages that have occurred. So there's quite a few messages here. This data set has lots of blanks in it and open information where it was expecting something but didn't find it. And so it's saying there's invalid dates. We're going to ignore those, but you can actually save all of these messages to a file if you need it for audit purposes or some other reason. But we'll close out from that error message. And now we have 3 data sets here. So the demographic data has all of the information about the subject that was collected, such as the age, the sex, the race, the ethnicity, the ARM treatment code, and actually the ARM of the study. And so all the demographics that were collected in the study are here. We have the exposure information, which is what drug was administered, and it'll have the time of administration. And then in the PC domain, we have the plasma concentration data. There are quite a few blanks because this trial included placebo subjects, and so there's no data for them because we didn't analyze the samples from the placebo subjects, but you can see that the concentration results are shown there, and the time points that they were collected are shown later in the data set. Now in my workflow, I've actually created some data links to the data, which makes it easier to import the data into my workflow. So here is my DM data link, and so if I come back here to setup and I just need to drag my DM file data file over to it, I can execute the data link, and then now I have current data in that data link. I'll do the same thing with the EX. Execute it again. And where this is really helpful is if you have a standard analysis that you perform, you can set up your workflows and analysis, have these data links here, and then when you have new data that comes in, either updated data from a specific study or even a new study, all you need to do is refresh these data links, and then all of the analyses that occur after that can be automated, and you can push one button on the workflow and rerun the workflow. So now that I've refreshed all these data links, we're going to need to prepare the CDISC data in order to analyze it with non-compartmental analysis techniques or whatever techniques that you might want to use. And there's a specific tool for this called the CDISC Data Preparer. And I'm actually going to switch over now to a second webinar where I already have the data, or not a webinar, but a second project where I already have the data imported. It's done exactly the same way, but I've already run through all of these objects so that they're ready to go. So the CDISC Preparer object can be added to the workflow. You can either grab it here. It's this blue and green circle that you can drag it onto the workspace, or you can actually take your data here, maybe your demographic data, and go to the results, and then you can send it to a data type, which is a CDISC Data Preparer. So in the CDISC Data Preparer, it's asking for up to necessarily 3 items, but there's a 4th for other findings that you might want to add. And so you need to add your demographics, your exposure, and your PK findings. So all that we have done is we selected the demographics data link for the demographics, exposure data link for exposure, and PC data link for PK findings. And we didn't set anything else. I added one item here, the treatment arm I added as a demographic so that I could have it in my data set so that I could sort data by it later. But all the other settings for exposure and for PK findings were automatically selected by the CDISC Data Preparer. And what this is going to do is merge all the data together into an analysis-ready data set for you so that you don't have to go through the exercises of several data wizards to accomplish the same feature. So when you actually run this, the result is you get two output data sets. You get a dose data set, and then you get a sample data set. So the dose data set contains all the demographic information, the administered dose, the units of that, and it includes the day when the dose was administered, and it even has the time that the dose was administered, and then it has the relative actual time and the relative nominal time, which were in the data set. So this has the dosing information, and for non-compartmental analysis, this can be used as the dosing information that you're going to use in your PK analysis. The sample data set includes the sample concentrations. And so we again have the subject numbers, we have the study days, we have time points, we have some demographic information that was included. We have the treatment arm. So we have the concentration result with the correct units included in it. So it's in nanograms per mil. And then we have the relative nominal time that is going to be used in this data set because there weren't any differences in the nominal time and the actual time. And so you see here we have all the concentrations, we have the limit of quantitation, and all the information that we might need for analysis. Interestingly, here's your results with your BLQ. Here's results that are numeric, and so obviously BLQ is removed or missing. So depending on how you want to do your analysis, you can take this sample concentration and run it through a BLQ object, or you can use it as is, depends on your procedures. So what the CDISC data preparer has done is actually taken all of the CDISC data that you have in these three different domains or data sets, merged it together into two analysis-ready data files, one with concentration data, and the second with the dosing information. And so now to use that data, I'll show you some examples of how it was actually used. So one way to use that data is to prepare an XY plot of the concentrations. And so I took the sample data directly out of the CDISC data preparer, and I made my selections here. I grouped it by subject. I did columns, lattice columns based on study day, and then I sorted by treatment, and I just plotted an XY plot of all the concentrations. And so what we can see here is that we have the supertherapeutic dose on day 1 is shown in this graph, and you can see all the individual concentration times, and then the supertherapeutic dose on day 6 is shown in this graph on the right with all the subject IDs. And I have the same results for the therapeutic dose that was used in this study. This was actually part of a TQT study. And so we've quickly taken data directly from the data preparer, and we've been able to generate graphics that we might need or use. Or you could generate graphics that you're going to use in your CSR, such as individual plots, or even take the data and modify it and do mean plots. Now I took made a few data changes in order to get the data down to a manageable size for pharmacokinetic analysis that has many, many subjects, and I wanted to reduce it, so I did some file preparations with column titles and things to make it easier. And then I did the same thing with the concentration file, and then I took both of these into a non-compartmental analysis object. So we have coming in here the concentration file that was prepared, and then the dose file that was prepared. So one of the major changes was that I made sure that the visit day was named the same in both the dose and the concentration files. The column headers were different because of the way that the CDISC data was set up. And so I adjusted those and I trimmed it down to just a few patients. And then I was able to run the analysis. And so you run the analysis and it generates all the pharmacokinetic parameters for these 32 subjects in this study. And then I can take that output. I generated some box plots for Cmax on day 1 and day 6 for the supertherapeutic and therapeutic doses. And then I set it up for AUC as well. So with these 2 plots that we have, These are graphics you may or may not use in a CSR. But I also created a table. And this table includes the Tmax, the Cmax, and the AUC last for the therapeutic and supertherapeutic doses on day 1 and also on day 6. So this is standard pharmacokinetic analysis that you might perform. There's nothing special with regard to Phoenix Connect around this, but what is special is the reporter tool, which is part of Phoenix Connect. And so this is connecting Phoenix to the outside world after you've done your analysis. So producing tables and figures and even listings within Phoenix that you can export to Microsoft Word. And so this reporter tool can be added most easily by going to the workflow. And you come down here and there's a little icon. It looks like a pencil on a piece of paper. And so you can drag that reporter tool and you add a reporter tool, and you can have as many reporter tools as you want. And let me show you what the reporter tool allows you to do. So in the reporter tool, you add content such as tables, figures, and then listings or text output. And then Phoenix will organize it into a Microsoft Word document, including captions on it. So in this example, I put the box plot for Cmax and then the box plot for AUC in here. And the way I would add those is I simply clicked Add Content. I went to my workflow and I selected I wanted the plot output from Cmax, and I clicked OK. And then it inserted that right here into the reporter tool. So I inserted both of those, and I put a section break. And what a section break is, right here, it allows you to change the orientation of the paper. And so for these first two, the default orientation is always the portrait mode. And when tables are wide, they don't quite fit on a portrait mode. And so I changed the orientation here with a section break to landscape mode. And so these section breaks are just used to switch back and forth and change the orientation of the paper. So the next thing I did is I imported a table. And so this is the table, the PK parameters. You see two boxes because the table has a split page based on the study day. So study day 1 is on the first page and study day 6 is on the second page. And that's why you see two boxes. So this will actually come up as two separate tables in our output. Now there's multiple options here. There's been other webinars that have gone over this, but I'll show a few things here. We can choose a caption, and so move this up a little. So you can type out what caption you might want to use, and you can actually use information from your data object in order to identify your caption. So this is a box plot of Cmax values following, and then it inserts the ARM variable here, doses on study days, and then it inserts the visit days. So this allows you to automate some of the preparation of the column titles. So if you want to have some specific language that you have in all the column titles, then you can include that in some of your data preparers, and so that it shows up in your tables, your captions later. You can also add footnotes if you would like, and you can add them in the same way. You can have abbreviations, and you can put text and format them. So I included two titles there, and then I included a title for the table. I didn't include any footnotes. And when you execute this object, it'll execute, and it looks like it maybe didn't do anything. It just has this results called a report. And when you click View an External Viewer, it will pull up a Microsoft Word, and then it will pull up the output. And so we have here box plot of Cmax values following supertherapeutic, therapeutic doses, because there were two. I didn't have a separation based on page, so there are two of those on study days 1, 6. And so you may need to do some modification to this text after it's here. But you can see they've inserted the figure already for you. Now we have the figure 2, they've auto-numbered it, and they have, again, the figure for you. Now you can see we've switched from the portrait mode to landscape mode, and we have table 1, which is of the drug following supertherapeutic and therapeutic doses on study day 1. We have that table, and now we have table 2 because it's a separate table on study day 6. So now we've exported these tables automatically to a Word document, which can then be simply copied and pasted right into a CSR, or even just provided to a medical writer, and then the medical writer can post them or add them to the CSR and stylize them the way you want them. You can include other specific information on these. Let me go back here to the setup. And so you can include perhaps the date and time that you ran these. And so let me run this again and generate a new report. So in this new report, we now have the figure with the title, and you can see down here below the figure, we've actually shown the date and time that we have executed that report, and so you actually have a timestamp on it. So that is a nice feature. You can also choose additional items such as the source, which will list the source where the information came from. So much like you source SAS files, this is actually going to source the actual Phoenix project file where that data came from. And so you can choose to add those features in as you need them in Reporter, but this is a fantastic tool for connecting Phoenix to the outside world of reporting where you need to report out your results. So I've showed you how to use, so there's one more item that I'd like to show you on CDISC is now exporting. So one of the important domains for submission is the PP, or the pharmacokinetic parameter domain. And we need to create that from our non-compartmental analysis. And so if we go to our final parameters file, we can actually send that, actually take that back. We don't need to send it. We go up here to File, and we're going to go to CDISC, SDTM, and we're going to export. And so it's going to ask us what domains we want to export. The only domain we really need to export is the PP domain. So we're going to uncheck all of these and leave the PK parameters. And it says, if we widen this out, I apologize, it doesn't want to. There we go. It says click to select the data source. So we're going to select the data source. We're going to select it from a Phoenix project. And we're going to select it from the non-compartmental analysis and the final parameters. So you don't want to choose the pivoted. You want to actually choose the final parameters. So you choose that, and then you click Next. And it's going to ask you for a bunch of options that somewhat looks overwhelming, but it really isn't. The first is to include RelRec, which is the relationship record, so it'll tell you which PK parameter was derived from which plasma concentration. So this is an important piece for submission to the FDA, so that they know that the AUC, for example, was calculated based on a certain number of parameters, or perhaps the what concentrations were used to estimate the terminal elimination rate constant. So we need to do a PP sequence, and this is just a sequence number. I default and choose to sequence it. So they're going to sequence it. Each observation or record is going to be numbered 1 through the end of the records. Everything else is automatically set up. You can choose to add columns if you'd like to add columns, but it isn't necessary. So they have character results and numeric results. But you don't need to necessarily fill all those out. It depends on your implementation of CDISC and your preferences. So you select the options. I usually just leave the default options there. And then I'm going to select Finish. It is going to ask me about preferred names for the PK parameters. Again, they insert some defaults for you. You can change those if you have some different settings. I'm going to leave them the same. I'll say finish. And now it is going to ask me where I would want to place that file. And I will say on the desktop. So it's going to be exporting. It doesn't look like it might be doing anything, but it will take a minute here to create all those files and export everything. It said there was a problem exporting. It doesn't like my validator, my CDISC validator. So it gave me that error. And so now I can actually go and find that file. So that export is added into this folder here called SDTM export. And you can see it produces a variety. Here's your export errors, but it actually produces the PP and the relrec XPT files. And so we can actually import those files if we wanted to. So you can see here is the PP domain, and you can see all of the PK parameters and their values and their units that are listed for you, and then the sequence numbers. And then you also have the relationship record. So you have the different relationships, IDs that are necessary. So it automatically creates that output. So now you can import the CDISC datasets, then you can conduct your analysis and actually export the PP and relrec domains and provide those back to the statistical group. And so now there's no programming needed necessarily. You've just used Phoenix Connect to actually connect to the SDTM data sets at the front end, and you're outputting SDTM compliant data sets on the back end that can be incorporated into submissions. So I'm going to move to another use of Phoenix that is really fantastic, and this is especially useful because Phoenix doesn't have the capabilities that all other programs have. So for example, SAS and R have some capabilities that Phoenix doesn't have because Phoenix isn't a programming language. And so one really good example is a forest plot. And so a forest plot, let me show you what a forest plot is. So a forest plot is commonly used to show relative exposure between two sets of variables. And so this is a really nice plot. It's really useful. Some actual drug labels have forest plots on them. These are very useful in bioequivalence and bioavailability studies. They're also useful for drug-drug interaction studies, especially when you have quite a few drug interactions that you're evaluating. Phoenix does not have the capability to build these forest plots. They have to be done manually, so that's something you could do in another software package. Instead of taking the data out of Phoenix and moving it to another package, what Phoenix Connect allows you to do is incorporate these other software packages within the Phoenix platform. So you can stay within Phoenix, but you can utilize all the advantages of some of these other software packages. So I'll show you how this is done. So this example is a forest plot, and what I have is some data. I'll show you here the data that I have. And so I've set this up in a specific way. I have a level, I have a group, I have a center point, a low value, a high value, and then a reference point. And so this is data that was that I'm going to turn into that plot that I just showed you. And then I have an R script that actually takes this data and turns it into that plot on a PDF page. So now I want to use that within Phoenix. And so on my workflow, I can create an R object. And so it's actually down here at the bottom. There's lots of there's annotations. You can have an R script. A PSN shell is a Perl speaks NONMEM shell. You can have an S+ script. You can have a SigmaPlot shell, and you can have a SAS shell. So these are all ways in which you can run another software package using Phoenix. So each one is a little bit different because each software package is a little bit different. But the basic structure that I'll use for R can be used for any of these others. So you select an R script, and you can drag it and you can drop it right here. And now you have an object that within this object, you can bring data into the object and run it, and you can get output from an R. And so you're actually running this R script within Phoenix. So let me show you how I did that for this forest plot example. So I created the R object, and then I created this script. And so everything from line 3 on is my R script. So this is the R code that generates this plot. And I don't know that I'll go through actually that R code and how it works, but this is just a standard R script. I included this line of code at the top, and this is what tells Phoenix how to attach the data. So use this align attach, and then parentheses input data, and it says pound WNL_IN, and then levels, group, cent, low, high, and reference. So essentially I'm going to say to WinNonLen, I need some input data, and I need these specific columns of or data in the file. So I need levels, I need group, I need center, I need low, I need high, and I need reference. And you can see here, these are the data columns, levels, group, center, high, low, and reference that I need in my R script. So the order didn't, it says right here, data columns names in the CSV file. So the order doesn't really matter, but they have to be there. So in order to do this, I write this down, I put that text in, and I click apply. And what that will do is create this input data. And so now an input data is available where I have to select, these are required now, levels, group, centered, lower, high, and reference. So these are the required columns for this R script to work, just like a non-compartmental analysis. So I drag in my forest plot data, and I happen to have the same name for my columns as I need. And so I can map them. I can map them differently if I want. It obviously wouldn't work if I did that with this example, but you can choose which columns you want to map. So they don't have to be named the same. It made it easy in this example. So I've now chosen what the data is that's going to go in. So it's essentially going to take this data and it's going to insert it into the R script. And then it says, what's my results folder? And so I pick a results folder that I'm going to have. And so then I execute this object. And so this is actually opening it up, and it is starting R in the background, and then it is running it. And then it provides me results. So it provides me R data, which is a workspace, an R workspace of all the work that was done. It has the log of so this is everything that happened in that R. So we came in here, and it said it started the WinNonLen imports, don't modify. The section, it brought in the input data, it read a table in, and so it read in this temporary table, and then it started the process of creating this forest plot with the commands that I had given it, the function to do it. So now we go and look, and I output to a PDF, and so there we are, there is our PDF file. So we've created this from the data that we had inside there. So really useful for that. Another example of R is doing PopPK diagnostic plots. And so you can have bring in data and do PopPK diagnostic plots within R. You can automate that and include it directly within your analysis. So if you have a specific way that you would like to show your data, you can do that. So a specific example of this is for a bioequivalence example. So in this workflow, I created an NCA object where I calculated the pharmacokinetics from a capsule and a tablet from some data. I inserted a bioequivalence object and calculated the bioequivalence, and now I want to create a forest plot of that for comparison purposes. And so I included a little data wizard to extract the data out of the bioequivalence that I was interested in, and then I created some specific formatting for the data. For example, the center point, the relative ratio is 114.20281. I don't want all those decimals, so I just wanted 114.2. And then for the low and the high, I went to 2 decimal places. So you could choose, actually, it looks like they went to 4 significant figures, not number of decimal places. So you can choose how you want to format your data. And then I had to create some levels, which is something that R needs. And so I enumerated the worksheet. This just tells the order that that things are going to be lined up. And then I included my forest plot R object. So I took that same R script and pasted it right in here. And I have the same thing. I have different groups, and the center, the high, and the low, and the reference. I go up here, and now I've pulled in different data. So you can see that there's lots more data here. And I can pull that data in, and my group is now called dependent. And so my different groups are the Cmax, the AUC, and 3 different AUCs. And now my center, my high, and my low, I've selected these modified ones because there's fewer decimals, it's easier to work with. And then the levels is that enumeration. So when I run this script now, again, it's going to jump out to R. It's going to run R and run the script. It's going to complete it, and it's going to come back here, and now I can view it in the external viewer. And so what I can see here is my bioequivalence example where I have my PK parameter, my 90% confidence interval, and I can see Cmax and the 3 AUCs and the point estimates, and then the actual confidence intervals on that, and it shows the relative ratio. So now this is a really easy way to say, was this bioequivalent or not? All of the AUCs are within range, but the Cmax is not within range. The upper confidence interval is outside the 80 to 125 window, and the lower confidence interval doesn't even cross 100, which is not necessarily a requirement. But this is a fantastic way to change it. And now, as an example of how I can modify this as 90% CI, perhaps I change that and want to say confidence interval. I can come back here and edit within my R script. And I know exactly where it is. It's right down here. So I'm going to change that to confidence interval. I'm going to say apply. And now I'm going to rerun this object. And when it finishes, that title will have changed in the output that was created. So we'll look at that output, and we can see it changes to confidence interval. It sort of runs off the side, and so I would need to adjust the font and do some other editing in that script to make it look nice and useful. So this is an example of how you can use Phoenix to connect to other software packages that may be useful. Maybe there's already some SAS programs or some R scripts or SigmaPlot scripts that you already have in use and that are really fantastic. You can just directly incorporate those in to your workflow, and you can use those, and then you can actually take this information and output it out to reporter functions and different things. So you don't even have to leave Phoenix to be able to use some of these wonderful software packages. So that concludes the demonstration portion of the webinar. So we'll come back to the slides now.
Now I'll turn the time back over to Andre to moderate the questions that you might have. If you have questions, and you can submit them through the question and answer box on your webpage.
Thank you, Nathan. Right now we will take some questions from the audience. One of the questions was, is there a written user manual for Connect? The only thing that was ever found was a video on YouTube.
So there is, and let me show you where you can access it through the Phoenix software. So in the Help menu, the second item is called Documents, and under Documents you have all of the user and getting started guides, and all of these are PDF documents, and so you can come down to the fifth one, and it's the Phoenix Connect 1.4 user guide. So you can open that up, and then the PDF document will open up, and you can print from it, or you can save it at a different location where you can readily access it.
Okay, great. One other question was, can you explain what you mean that R runs inside of Phoenix, and does the audience need a license for R2? R as well?
Yeah, R2, it's like R2D2. So any of the Phoenix Connect objects that utilize external programs, you would require that program to be installed on your local computer or the server if you're running something on a server. So the different objects that you can see here, there's and I'll actually drag them up here. And these are the different objects or different software packages that you could run. So for each of these, for SAS, SigmaPlot, S+, and R, as well as Perl Speaks NONMEM, you would need an actual, forgot one more here, NONMEM. You would need that software installed on your computer, and the Phoenix Connect user's guide that I just showed you will tell you how you tell Phoenix in the preferences where the software is located. R, for example, is a free software, so the license is free. You can download that installed on your computer. You tell Phoenix where it's located, and then you now have access to R. The same would be true for any of these other software packages.
Okay, great. And one of the last questions that came in, can you customize the SDTM data formats?
So there's, while SDTM is a standard, there's a lot of different flavors or versions, you might call of it. Some people call it SDTM plus, SDTM minus, and it's where each company or organization has customized the SDTM to fit their specific needs. So the basic structure of the data is the same, but perhaps they have extra columns or additional information that they like to include in their data set. So it can be customized using XML files, and there's specific instructions on that in the user's guide as well as through the the Certara support team. You can do some minimal customization through the options that I showed in the walkthrough, and where you export, so you can choose parameter names, and you can choose which columns to export using that standard tool, but you can actually do a little more customization with XML files that you add in, that Phoenix will read those XML files and then use them to export the PP and the RelRec domains for you. Okay, great.
We have some other questions coming in, actually. Can I have SAS or NONMEM installed on a remote server and still submit jobs?
So I'm going to see if Aaron has the answer to that one, because that's a very technical question that I don't have the answer to. Aaron?
Yeah, hi, this is Aaron Guinan, the Director of Deployment Services for Certara. We do have some clients that utilize the technology that we call the JMS server to execute SAS or NONMEM on a remote location. And essentially it uses a remote execution from the Phoenix platform. You specify your R script or your SAS script just like you would if you were running it locally, your NONMEM control file, things like that. And then you can perform a remote execution from the Phoenix platform and just define the location of that JMS server to push jobs to these remote locations. Then the results from those executions are then returned back into the Phoenix platform. So it is possible to set that up. There's an additional license cost for JMS, and then there's typically some services around just configuring that for a client.
Okay, great. And there was another question. Can we use Windows Editor? Can we use any Windows editor we want to edit the scripts, or do we have to use the built-in editor?
So
I'm
on
not
that,
sure if that would be posed to Aaron.
I can actually answer this one. So the script can be written anywhere. It needs to be within the object in order to be executable. And so if I show the forest plot script text here, the text would need to be within this area in order to be executed by Phoenix Connect, but I can actually edit and modify this text outside of this